The first question you have on Tuesday's Daily Math asks you which model shows the equivalent fractions 3/12 is equal to 1/4. What does equivalent fraction mean, Harper?
It means like equal to.
They're equal. They show the same amount. Okay, so which one shows that 3/12 is equal to 1/4, Scotty? The first one, option 1. The top model has 3 pieces shaded. There are 12 pieces in the whole. And the bottom model shows 1 piece shaded, 4 in the whole. So that shows us that 3/12 is equal to 1/4. Which one of these options is not equivalent fractions? Which one does not show equivalent fractions, Olivia?
On the third one.
That's right. Option 3 is not equivalent. All the rest of them are equivalent fractions. They just don't show the amount 3/12 is equal to 1/4. All right. And the second question asks you which model correctly represents the problem. So we've got addition of fractions. They've changed them or converted them to mixed numbers. And there is a model. We have to make sure that all 3 of those are correct. Christopher, what did I ask you to do with the Chromebooks? What did I ask you to do with it? Thank you. All right, so option 1, 6/9 plus 7/9. What do we have to check before we can add or subtract fractions? What do we have to check, Olivia?
The bottom number.
The bottom number. We have to check the denominator, and they have to be the same or we cannot add or subtract them. Is our denominator the same?
Yes.
Yes, it is. 6/9 plus 7/9. How would I do that, Caden?
When I went through every single one and then added 6 plus 7 and until I got to the first one and
So what is 6 plus 7? 6 plus 7 is 13. And so we should have 13/9. But option 1 says 11/9. So we know that's not correct. Option 2 says 10/9. That can't be correct either. Okay. Then we have 6/9 plus 7/9 equals 13/9 here on option 3. Is that correct?
Yes.
Okay. So if I take 13/9 and I break that into, I can use a number bond to find my mixed number. How many ninths does it take to make a whole?
9.
It takes 9/9 to make one whole. Okay, so if I take 9/9 out, how many do I have left, Caden? 4/9. Okay, so we can see that 13/9 is equal to one whole and 4/9. So does our mixed number match?
Yes.
All right, let's check our model. On our model, do we have one whole shaded and 4/9 more?
Yep.
We do. So option 3 is the correct answer. All right. Next, we have an area model, but we have some missing parts. My equation or number sentence says A times 58 equals 2,494. Then we have an area model. They drew an area model for us. And we have B and C missing in the model. So how in the world am I going to find A, Christopher?
Well, you would go down to the area model and then you look at 40 and then you would look at your options and if there since there's like no other 40 no other thing that would go with 40 you do 42.
And B is only asking 40 plus what?
3.
Okay, so we had to solve that, right? How did you know that B was going to be 3?
Because when I looked at my options, I saw 43. And that was the only option with like.
Okay, how could we, if we didn't have multiple choice, how could we figure that out? If you didn't have options, how could we find A and B? Jacob, what could we do?
You can multiply you can start multiplying numbers by the 50.
Okay.
And since the answer right there is 150, then you would have to get 150.
Yeah, we're looking for 50 times what number would equal 150, and that is 3. So we know that B is going to equal 3.
Then A would be.
And so then that tells us for A we need 40 plus 3, and that is 43. So A equals 43. So I found A and we found B. How are we going to find C, Dylan?
So you the 40 and the 50, you have to tie them together.
Yes, sir.
And I got it. So it's just like 5 times 4, you get 20. So that's what I did. And then I got 2,000.
2,000. Very good. You multiply 5 times 4, that's 20. And we need to put 2 more zeros at the end. So our answer to C is 2,000. Okay? The next question tells us to use the commutative property to solve. What does the commutative property of multiplication mean? It is kind of a weird word.
Is it where you switch the numbers around?
Yes, it means that I can move the numbers around in whatever order I need to. As long as I'm multiplying, it does not matter which order I multiply in. So if I look at this first line, 7 times 11 equals what times 7? What's missing to make those the same, Ansley? 11. So I know that A is going to be equal to 11. And then to find B, I need to solve 7 times 11, which is what? 77. And 11 times 7 is also 77. And both of those numbers are the same. They're equal, so I know that's correct.
I just walked it around pretty much.
Okay, yeah, that's exactly what you're supposed to do. All right, let's go ahead and solve this last question. It says, select the diagram and answer that matches this problem. Corey has 63 stamps and 9 coins in her collection. How many times as many stamps does she have than coins? So, how did you solve that, Cash?
I saw that the third one had not.
I just knew that one was right.
Okay.
I thought that the first one was right, but then I saw that the coins were more.
Yeah, exactly.
I picked it.
Yeah, we know it tells us in the problem that it's 63 stamps. So we know that option 1 can't be correct because it has 63 coins and that doesn't match. Okay, so then how did you know that it was going to be option 3?
Because all the others didn't have 9.
Didn't have 9s in them, exactly.
That's how I got my answer.
Okay, option 3 is correct. If we did 63, the total number of stamps, we're looking for 63 divided by what equals 9, or we could switch that around as 9 times what equals 63. Yes, ma'am. Yes.
The way I thought my answer was, I looked at option 1 and I saw that it said 7 times as many coins as stamps when it says in the question how many times as many stamps as coins.
Very good.
Then I saw that the others don't have 9, so I did.
Very good. All right, questions on today's daily math?
No,
All right.